Look at this example problem. See, here we are going to use Bayes theorem and solve this one. Okay, simple example. And also one more, you can say an additional point. This particular problem is actually very important from your board exam point of view. Okay, look at the question. It says, suppose that the reliability of a HIV test is specified as follows. Of people having HIV, 90% of the tests detect the disease, 10% go undetected. All right. Of people free from HIV, 99% of the tests are judged HIV negative, but 1% are diagnosed as HIV positive. From a large population of which only 0.1% have HIV, 1% is selected at random, given the HIV test, and the pathologist reports him or her as HIV positive. What is the probability that the person actually has HIV? Okay, there are a lot of information which is there in the question. Let's try to break it down as to what is what and what we need to find out. Okay, see here, we'll start with the question here. What is the probability that the person actually has HIV? Isn't it? The person should has HIV. So let's look at what are the things which are given to you. See, let's define two events. Okay, so the first event we'll call it as E. All right. This event is where the person has HIV. Okay, this is one event. Say we have another event A. Okay, another event A where we can say that the person is diagnosed positive. Fair enough? So we'll talk about two events. Now the question says, what is the probability that the person actually has HIV? That means we are trying to calculate P of E given A. Correct? Remember, this is what we need to find out. What is this? Isn't it? Now let's write down what is given and what we can do about it. All right. So let's look at the first one. So we have of the people having HIV, 90% of the tests detect the disease, 10% go undetected. Correct? Okay, this is one part. See what is given, that first we'll try to calculate P of E, that is the probability that the person has HIV. Look at the question. It says from a large population of which only 0.1% have HIV. That means P of E is going to be 0.1%. 0.001. So, probability of the person not having HIV, P of E complement, would be 1 minus 0.001, which is 0.999. This much we know, right? Now what we'll do, we'll look at the second case, that is P of A given E. That means probability that the test is going to give us positive given that the person has HIV. Look at the question again. It says, of the people having HIV, 90% of the test detect the disease. That means the diagnosis is going to give us positive given that the person has HIV. That's nothing but 90%, isn't it? Make sense? So what do we have now? That we have P of A given E. This is going to be 0.9, 90%, isn't it? Now same way, what do you think is P of A given E complement? This is going to be the rest 10%, correct? Here we take 0.1, 10%, correct? Now we have everything. So let's look into the formula, that is the base formula. Now one thing you should understand, that E and E complement, they are partition sets, correct? So E union E complement is going to give us the total set, that is a sample space. We'll make use of this particular concept. Fine. So let's write down the base formula, like what is what and what we have. Everything we can write down. We can solve this problem. See, we have P of E given A is nothing but P of E into P of A given E divided by P of E into P of A given E plus P of E complement P of A given E complement. Right? So this is what we have. Guys, we know everything on which is there in the RHS, isn't it? Let's substitute. P of E is 0.1%, 0.001 into P of A given E, that is 0.9 divided by 0.001 into 0.9 plus 0.999 into 0.1. Correct? So if you solve this one, you are going to get an answer 0.083 approximately, like on an average. So this is going to be the answer. So we can say that P of E given A is going to be 0.083. This is the given answer. Fair enough? So whatever you're seeing, no, the probability that the person actually has HIV and it is going to get detected by this particular test is so much. Fine. So this is one example of how we use the Bayes theorem. Understood? So few more problems you will see in the next video.